Alright, so first lesson is solving inequalities by addition and subtraction. The addition and subtraction property of equality says that if a is less than b, then a plus any number c is less than b plus that same number, and if a is greater than b, then the same follows, that a plus c will be greater than b plus c. If a is less than b, then a minus c is less than b minus c, and if a is greater than b, then a minus c is greater than b minus c. Obviously the top one is addition property, and the bottom one is subtraction property. Okay, so the first one, x plus 7 is greater than 5. We're just going to solve this just like it would be an equation. So our first step, we're just going to subtract our 7 over to the other side. And that's going to cancel, and x will be greater than negative 2. Basically the same as if we were doing an equation. Okay, first of all, when we write our final answer, we can write it, just as we did on that last problem. Or there's also something called the set builder notation that says the solution is the set of x for which x is greater than some number c. So when we graph linear inequalities on a number line, like let's say for example we have x is greater than some number c, or x is less than some number c. When we graph this, at c, there will be an open circle because we're not including that number. If we were to have x is greater than or equal to c, or x is less than or equal to c, then when we graph this on a number line, we're going to fill that circle in because we're including that number c. Okay, here's a couple of examples. Make the second one there. So the first one, solve n minus 12 is greater than negative 4. So what we're going to do, again, add 12 over to the other side. So I have n is greater than 8. So then we graph this. 3 numbers is probably enough. 7, 8, 9. Again, this is just greater than, so we're going to put an open circle at 8. Then which way is that greater than? That would be to the right. On the next one, we'll subtract 4 from each side. Make sure we keep our inequality the same, so it's p is less than or equal to 3. So now I graph 2, 3, 4. Now this one will be a closed circle at 3 and pointing to the left. Here's a couple of problems that have the variable on both sides. So our principles are going to remain the same, but we're going to try and combine our x's. So this first one, the one thing I will say is try and get your biggest x over to the same side. So like this case, my 4 is the biggest, so I'm going to move my 3x over. So I'm going to subtract 3x over. And then make sure I keep my sign, negative 4 is greater than x. Another way I could write this, especially for graphing purposes, is to turn it around so that its x is less than negative 4. Okay. On the next one, the 5 is the biggest one, so I'm going to subtract my 4a over. And when I subtract that over, I'm left with a plus 6 is greater than 0. So then I subtract 6, and a is greater than negative 6. Okay, one number, this one's just going to be write and solve a one variable inequality given the written sentence. So this one says 3 times a number is less than the difference of a number and 7. So first of all, we have a number, so we can define a variable. We'll just call it x. So 3 times a number, so 3x. Notice when we said is, that was like equal sign, but now it says is less than. So we'll have less than the difference of a number and 7. So difference means subtract, so x minus 7. Okay, we could solve this out. If we do, we would just subtract our x over. We'd have 2x is less than negative 7. You you divide by 2, which again, that's more next section, but if I divide by 2, then we end up with x is less than -7 halves.